I don't like concrete.
Oh, yes.
Okay, so this is a pretty complicated integrand. It involves some trig, it involves multiplying it by 4x cubed. What do you think might be a good option to use for u? Let's let u be x to the 4th plus 2. So then what would du be? 4x cubed dx. Does that work out nicely for us? Yes.
Will you give us a problem that doesn't as well with like that?
We'll get to some where you have to do some adjusting.
Okay.
You may not have to rewrite it this way. I may be taking an extra step that you don't need, but I like writing it this way right now so that you can tell, isn't this exactly what du is? So I can now do a u substitution. I'm substituting u in for a more complicated function. Cosine of u du. Should you be able to integrate that quickly?
Yes.
Yes.
Sine u.
Sine u plus c.
So sine of u
And that's sine of
plus c.
x.
And that would just turn into sine of x to the 4th plus 2 plus c. Ma'am? You got, that made it a little bit easier to see it there. And hopefully you can see where this is helping us tackle that issue of the chain rule for derivatives. Okay, so let's try another one. How about the integral negative 3x over 5 minus 3x squared to the 1/2 dx. Is this one of my note card rules about integration? Absolutely not. That's so complicated. It's got exponents, even a negative exponent, division, all kinds of mess going on here. Now, are you always going to choose the correct u the first time? No. If you choose a u that doesn't work for you, then try to figure out another u. What does it look like this u would need to be? 5 minus 3x squared. So then du would be negative 6x dx. Do I have a negative 6x dx in here?
No.
I don't. But don't I have something close to that?
Yes.
Okay, so there's a way that we can work around this. Well, if I multiply it by 2, aren't I going to change the value of the function?
Yes.
But don't I need a 2 in there? So here's what we're going to do. How about if I multiply it by 2? But isn't that changing the value of my function? If I multiply it by 2, I would also have to divide it by 2. Is that changing the value of my function?
No.
I've really multiplied it by what value?
1.
Just 1. Now what I can do is group all of this together, and I'll pull out the 1/2 that was right here. Then I still have a 5 minus 3x squared to the negative 1/2, and now don't I have my negative 6x dx? So you see I had to put in a 2 and also divide by 2, so that I was not changing the value of the function. Was that difficult to do?
See how she
No.
did 2, she multiplied it by 2 over 2. Well, she pulled out the top 2, because she had to pull out the 6x, so when she multiplied 2 times negative 3 is equal to 6x. She pulled it out to the bottom.
You see all of this turns into this, which can be substituted by that. So you have to be creative. You have to find a way to make this match your du, but then you also have to make sure you're not changing the value of the function. So now this is simple to integrate. U to the 1/2 times 2, they would cancel, correct?
Yeah.
So yeah, this is just u to the 1/2 plus c. That would turn into the square root of
3x squared
stop the video there, please?